Hello and welcome to today's session. So in the last lecture you have seen the working of the JFET transistor. So now in this lecture you will going to see the characteristic graph of JFET. So you all know that the JFET output characteristic graph looks like this, where the current reaches its maximum value. So this we call it as IDSS, the source to drain saturation current. This y-axis is your ID, current, and this is your VDS, source to drain voltage, and this whatever the maximum current you obtained, this is for VGS is equal to 0 volts. So when VGS is equal to 0 volts, the maximum current that you will receive, so this current we call it as IDSS, drain saturation current, and the voltage at this point we call it as VP, that is nothing but the pinch off voltage. So now likewise, if you increase the gate to source voltage, so in this case the gate to source voltage, as we have seen before, so we have to apply the more and more negative voltage, so it will get saturated to lesser and lesser values. So like this you will get this graph. So on the other end, now this is all the positive values because the source to drain voltage is positive voltage. So here this is 0, it might be 1, here it is 2, here you can consider it as 3, 4, 5 and so on. And likewise you have seen on the left side we will get one more graph. So this graph we call it as a transfer characteristic graph, and here the voltages are negative voltage. So these are all negative voltage. So -4, -5 and so on. So this is given as, so this point is where the VGS is equal to minus VP. So that is the point. So this point is nothing but, so VGS is equal to minus VP, at which the drain current will become 0. So this is the transfer characteristic graph on the left side. So that can be drawn with by extending these points like this. You will get this one more point here, and likewise you will get one more point here. So likewise we get the values of ID, and with respect to VGS we are going to plot this. So this is VGS versus ID graph. So this graph on the left side, what you're seeing here, this we call it as a transfer characteristic graph, and the right side of the graph we call it as the output characteristic graph. So output characteristic graph, and this is transfer characteristic graph. Okay, so now we'll see the equation, the source to drain equation. So these equations are represented by two equations, that is ID is equal to IDSS of 1 minus VGS by VGS of whole square. So what is this VGS of? So as you can see from this graph, so this point we call it as VGS off, means at this point what happens, the drain current is almost 0. It means that JFET is off, it is not on, because the source to gate voltage is so high, it is not allowing the JFET to turn on. So that voltage we call it as VGS off voltage. So as we all seen that VGS is equal to minus VP, so this VGS off can also be written in the form of VP. So the same equation can be rewritten as ID is equal to IDSS of 1 minus VGS by VP whole square. Okay, so this equation we call it as a Shukli's equation. So this is the graph which you can see, which we have drawn before. So this is the right hand side is the output characteristic graph, and the left side is the transfer characteristic graph. So if you can see this point which is shown here, this is VP point. Okay, so VGS is equal to minus VP. So if we rearrange this equation, the drain current equation, then we can obtain the equation for VGS. So VGS is equal to VP into root of 1 minus ID by IDSS. Okay, so now so how to obtain this transfer characteristic graph? So there are few points. So let me save this. Let me save this. Let me save this as page 3, and let me get the new page here. So now, to obtain the simplest way of obtaining the transfer characteristic graph is by using this equation, that is id is equal to idss of 1 minus vgs by vp whole square. So now in this equation we will consider few things. Now if vgs is equal to 0, then what happens to this equation? In this equation, if vgs is equal to 0, then your id is equal to id, this is equal to idss. So it means, if you can see from the previous graph, now let me open this page again. So if you can see from this, when vgs is equal to 0, then id you will obtain as the maximum, that is idss. So that you can obtain from this point. So this point is nothing but the point which you have discussed. Now if vgs is equal to vp, then what will happen? If vgs is equal to vp, then id, so here you replace this vgs by vp, so you will get it as 1, so 1 minus 1 you will get it as 0. So your id will become id is equal to 0. Now another consideration is, we will take one more equation, that is the vgs equation. So vgs is equal to vp into root of 1 minus id by idss. So let us take that equation. So vp is equal to, sorry, let me clear this section. Yes. So vgs is equal to vp into square root of 1 minus id by idss. So in the second equation, if we consider, id is equal to idss by 4, if you consider here this is idss by 4, then here we will get vgs is equal to vp by 2. vgs is equal to vp by 2, and then if we consider id is equal to idss by 2, then your vgs is equal to 0.707 into vp. This is point, so 0.707 into vp. Now by using these points, let us see how to plot this graph. So let me plot here. We are plotting this graph for n-channel JFET, please remember that. So now this y-axis is nothing but your id, and this x-axis on the negative side is nothing but your vgs. Okay, so since we are plotting this transfer characteristic graph for n-channel JFET, so again and again I am reminding, your x-axis for your VGS is nothing but negative values. So this is all negative values on the x-axis. So it is -2, -3, it is something like this. Now what may be the value? We will just consider the maximum case, just a general case, sorry. So the first case is when VGS is equal to 0. At this point, what happens to ID? ID is equal to some value, that is IDSS. So this point is nothing but your IDSS. So we got 1 point. And second point is, so when ID is equal to 0, VG is equal to VP. So in this example, let us consider VP is equal to 5 volts. So 5 is nothing but -5 here. So let us take some point here that might be -5. So this is your VP point. Now let us take IDSS is equal to 8 milliamperes. Then in the second case, when 8 by 4, So for 2 milliamperes, somewhere here, so what is the VGS? So VGS is equal to VP by 2. So VP by 2 is somewhere. So you will get one more point here at minus. Here you will get one more point at minus 2.5. And for IDSS by 2, you will get, that is for 4 milliamperes, you will get one more point somewhere here, that is a 0.707 of VP, that is somewhere you will get here. Now if you join these points with respect to the graph, so you will get a graph like this. So this graph, this is how we can plot the IDSS. This is how we can plot the transfer characteristic graph for n-channel JFET. Hope this is clear to you all. Now we will look at a few examples with respect to this. So let us quickly see the example. So here there is an example. So for n-channel JFET, IDSS is equal to 8 milliamperes and VP is equal to minus 5 volts. So we have to find the ID for two different value of VGS. So to find the first sub question here, ID, so we'll use this first equation, that is ID is equal to IDSS of 1 minus VGS by VP whole square. So in this case, IDSS value is given, that is 8 milliamperes, VP is given minus 5 volts, and VGS, first we substitute minus 2 volts, you calculate. So for the first case, we will get ID is equal to, we will get this answer as 2.88 milliamperes for the first case, and ID for the second case, that is for VGS is equal to minus 3 volts, we will get this as 1.28 milliamperes. And for the second case, to find the VGS, we use the second equation, that is VGS is equal to VP into root of 1 minus ID by IDSS. And here you substitute the different values for ID. So then we will get VGS for the first case, that is for ID is equal to 3 milliamperes. We will get this as minus 1.94 volts. And for the second case, VGS, we will get this as minus 1.05 volts. So you can, it's a simple calculation, you can substitute the values and you can find it. So there is a next one more example is there. So a JFET is operated at a Q point where its IDQ is equal to 4 milliamperes and VGS is equal to minus 3 volts. So determine IDSS if VP is equal to minus 6 volts. So we'll use the same this equation, that is ID is equal to IDSS of 1 minus VGS by VP whole square. So substitute all the values and you will get the answer. So I'll leave it to you to calculate these calculations. So these are the simple examples which you can work out, and hope you all have understood this session. Take care, goodbye. We will continue with the next session with P channel JFET, its plotting, its operations and its transfer characteristic and output characteristic graph. Thank you.